Welcome back to this second video. We're going to start with question 12. And then for question 12, we have something called a residual plot. So this diagram right here is your residual plot. And then we just have to look at something real quick. So for this one, what do you notice from that residual plot? So for the residual plot, I can see that there is a pattern. So you can see that there is a pattern. So look at all those points, they follow a particular pattern. And then we know that if there is a pattern, it means that the model is not appropriate. So it means that this model is not appropriate. And then let's look at the answer choices that says that this model is not appropriate. So if you look at option A is saying that that linear model is not appropriate because we have a clear pattern in the residual. So the right answer would be option A. So that would be the right answer to that question. So remember, if you have a pattern, then that model is not appropriate. If there is no pattern, it means that the model is appropriate. Now let's go to question 13. For question 13, we have the same thing. So if you look at the first residual plot, you can see that that first residual plot, we have that one to be exponential. And then the second one, we can see that this one is a linear. So what do you notice? So in this the first one, which is exponential, I can easily see that there is no pattern on this first one. So I can easily see there is no pattern on the first one, which means that if there is no pattern, it means that that model is appropriate. So it means that the model is appropriate. And then for the linear one, we can easily see that we have a pattern for that one. So we can easily see that there is a pattern. There is a pattern for this one. And in summary, it means that this model is not appropriate. Is not appropriate. So in that case, we just have to pick the answer choice. And then if you look at the answer choice, because of that, we have that exponential, and is looking at that exponential, it is appropriate because the residual does not show a clear pattern. So you have to be careful about that because that one says exponential. Now let's go to question 14. For question 14, we have to be very careful on question 14 because we have a table, and then it's saying that we have a table, and then it's saying that values of f and g are given in the table for selected values of x. And then it's saying that h of x is equals to f of g of x. And then which we easily know that this one is the same thing as f of g of x. And then what the question is asking us to do, the question is asking us to find h of 2. So we are told to find h of 2. So which means that all I have to do in this case is to do h of 2, which is the same thing as doing f of g of 2. That's the meaning of that, which means x is equals to 2. And then if you go back to, this table real quick, let's go back to x is equals to 2. And then let's find the corresponding value for s is equals to 2 for g of 2. So in that case, we're going to have that one to be equals to 3. So that one is equals to 3 right there. So which means that in this case, I have f of 3 because my g of 2 would give me 3. So my g of 2 is going to be equals to 3. Now let's go ahead and go find f of 3. So which means that, I'm sorry about this. This one should be negative 3. I'm sorry about that. That one should be negative 3. And then in that case now, what is f of negative 3? So I'm going to go to negative 3. So I'll go to my table, and then I go to negative 3, and then I find the corresponding value, and then the corresponding value would be 2. So which means the answer to this question would be equals to 2, and that's option D. And then let's go to question 15. For question 15, we are told to find the inverse of g of 2. So what do you notice? So first thing I will have to do, let's ask ourselves, what is g of 2? So go back to that table. From that table, I can easily see that my g of 2 is right here. So my g of 2, I have 2, and then my g of 2 is negative 3. So that one will mean that I have this one to be, negative 3, and then which means that, if I do the opposite, so if you go back to your table, and then to find the inverse of negative 3, which means that the inverse of negative 3 will be right here. So I have negative 3, and then to do the inverse, I have to trace it back to the input value, and that one will give me 0. So that one will give me 0, and that one is option B. And then let's go to question 16. Question 16 is saying that we should find the average rate of change. So for this question, I am told to find the average rate of change. So I will do the average rate of change. So let's do the average rate of change real quick. So and then my formula for the average rate of change. So let's call it error. And then that one will be equals to, and then if you look at that, and then because we're doing the average rate of change of f, that one will be f of b minus f of a divided by b minus a. So which means that I have my error is equals to f of my b. In this case, this will be my a, this will be my b. So my b in this case will be f of 5 minus f of negative 3 divided by, I have 5 minus negative 3. So let's simplify this. And then if you go back to the table, let's go back to the table. F of 5 in this case is 0, and then f of negative 3 is 2. So if I substitute everything that I know from that table, my f of 5 is 0 minus, and then f of negative 3 is 2. So that one is going to give me 2 divided by 5 plus 3. And then if you simplify all of this, you notice you are going to get negative 2 divided by 8. And then we simplify this to the lowest time, we're going to get negative 1 over 4. And that option would be option D. And then let's go back to this question real quick. So if I go back to this question right here, and I know that this particular point right here, this point is g of 1 is equal to 9. And then I know that this point right here will mean my g of 2 is equals to 6. And then I know that this point right here is g of 3 is equals to 4. And then what do you notice? So I can just stop right there, and then I know that this this diagram that I have, or the graph that I have, looks like exponential. That's an exponential function. And in that case, because that's an exponential function, we know that that is a geometric series. That's a geometric series. All we have to do is to write down our formula. So our formula for that geometric series is this that we have, the general formula for that. So all I want to do is to, pick these 2 points. So I'm picking these 2 points, and then I will use those 2 points to find out what my common ratio will be. So in that case, I said that my g of n would be equals to g of 2, and then my g of k will be g1, and then which means my n will be 2, and my k will be equals to 1. So if I substitute everything I know from that, graph, that my g of 2 is 6. So my g of 2 is 6, and then my g of 1 is 9. So my g of 1 is 9, and then you have your n to be 2, and then your k to be 1. And then if you subtract 2 minus 1, you're going to get 1, and r raised to power 1 is still the same thing as r. And then let's solve this one-step equation. So if I solve that one-step equation, I notice that my r will be 6 divided by 9. And then if you simplify that to the lowest term, you have 2 divided by 3. And then in that case, all I have to do now is to substitute back into the formula. So let me write down the formula one more time. So the formula that I have will be Gn is equals to Gk r into n minus k. And then in this case, because I am looking for the general expression for that, which is the general term, which means that my Gn is the general term. And then in this case, I wanted to use my Gk as G2. And then my R is the same thing as, I just calculated that to be 2 over 3. And then my n is like, leave your n like that, minus, in this case, my k would be equals to 2. So my k will be equals to 2. So I have my k to be equals to 2. And then if I simplify this real quick, I have my gn. My g2 will be 6. And then this one will be 2 divided by n minus 2. And then if you look at that, and that option would be option C. That option will be option C. And then let's go to question 18. For question 18, we have this table right here. And then if you look at this question, I picked the important point from this table. So which means when I pick this point right here, so when x is equals to 9, when s is equals to 0, I mean, y is equals to 9, which means this particular point is your y-intercept. And then I pick another point. So I pick this point when x is equals to 2, y is equals to 3. And then I pick this, some key point. I pick this one right here when x is 4, y is 2. And then I pick this point when x is 6, y is 1. And then I pick this s-intercept when x is 8, y would be 0. So in this case, this table, this question wants me to find the inverse of that particular graph. Now, to find the inverse of that particular graph, what are you going to do? So to find the inverse of that graph, I just have to switch x and y. So I just have to switch x and y. So if I switch x and y, I have this one to be 9, 0. I have this one to be 3, 2. I have this one to be 2, 4. I have this one to be 1, 6. I have this one to be 0, 8, which means that this, my new y is my inverse of x. That's the meaning of that. So if you look at the graph that, which of this graph is going to produce, this this table right here, which of the graph is going to produce that table? And that graph, if you look carefully, and that graph would be option B, because I just said that when x is equals to 0, you have your y to be equals to 8. And then if you go further, when x is equals to 3, you have your y to be equals to 2. And then if you go further, when x is equals to 1, then you have your y to be equals to 6. And that is the graph that gives us this table right here. Now let's go to question 19. For question 19, we have this exponential function. So my exponential function is given. So let's go to question 19. For question 19, my exponential function is given to be that's my exponential function. And then is asking for which of these following is true about that. Now, the first thing you have to notice is, let me rewrite my exponential function right here. So you have this, and then you have 2 divided by 3 raised to the power x. And then I know my exponential function, this right here is my y-intercept, which is a, and then this is my b. So that's my base, and it's the same thing as my common ratio, because exponential function is geometric series. And now what do you notice about b? Your b is equals to 2 divided by 3, and then I know that 2 divided by 3 is 0.6, approximately 0.667, and then which I know that this is less than 1. And then there is a condition that says that if your a is greater than 0 and your b is between 0 and 1, this one means you have exponential decay. That's a condition for exponential decay. But I want you to note something. But if you notice that your a is greater than 0 and then your b is greater than 1, this one is exponential growth. I want you to know the difference between these two. This one is exponential growth. And now, what do you notice? My a is 7, which is greater than 0, But in this case, my b is between 0 and 1. So which means that I am going to have a graph that looks like this one. So we're going to have a graph that looks like exponential, decay. And then if you look at that exponential decay, and then we said that the y-intercept should be 7. So, and then if you look at that graph, what can you notice? This graph right here is a concave up. That graph is a concave up. And if that graph is a concave up, what else do you notice? I notice that that graph is also decreasing. How do you know that that graph is decreasing? So let's say you're standing right here and then you want to slide down. As you're sliding down, you're decreasing. So in that case, that option would be, so as I said, this one is decreasing also. It's decreasing and then is concave up, and that option would be option A. That option will be option A. As I said, this condition is something you want to have handy, and then this condition is something you always want to remember. And let's go to the next question. So the next question that I have says that the graph of K is shown in the figure above. Which of these best describe the behavior of the graph of K from point A to point B? So we are told that which of that describe from this point A to point B. So what do you notice? So from point A to point B, first thing that I notice that this is increasing. I notice that this is increasing. It's like climbing a mountain. The second thing that I noticed that this is this looks like a concave up. That's not concave up. I mean, it should be concave down. My bad. That's concave down. That's concave down. And then if that one looks like concave down, which of this graph, which of this option is the right answer? The right answer will be option B, because K is increasing and is concave down. Now let's go to question 21. For question 21, we have the function g is a polynomial with the n behavior. And we know that for n behavior, we are going to look at the n behavior on the left, and then we look at the n behavior on the right. So in this case, it's saying that looking at this real quick. So looking at this one, as it means that as x tends to negative infinity means that as x decreases without bound. And if x decreases without bound, this one means this is the left. Because on your number line, you're going to have your negative infinity on the left. And then if you look at this one right here, this one right here means that x tends to infinity, which means x increases without bound. So in that case, we're given that our end behavior, and then this one is your right. That's your right. And then there's a condition that always starts from the right. So if I go to the answer choices, and then I will start from the right. To start from the right, let me start from option A. To start from the right, I will look at the leading coefficient. So the leading coefficient for this one is what? -3. So my leading coefficient, I will write down as LC. Leading coefficient is -3. You notice that that one is less than 0. And then we said that if the leading coefficient is less than 0, it means that your limit as x tends to infinity of g of x, because that one is less than 0, it means that this would be negative infinity. That one will be negative infinity. And then now we can now look at what is going on the left. So looking at what is going on the left, all you have to do is to check the degree of that polynomial. So the degree of this polynomial is 5. So my degree is 5. And then because my degree is, because it's 5, that is odd. That's odd number. And because it's odd number, we're going to do the opposite of this right hand behavior. So we're going to do the opposite of negative infinity, and then the opposite would be positive infinity. So the answer to this one will be limit as x decreases without bound of g of x, and what will be the opposite of this? And then the opposite of that would be infinity. And then if you look at that, in fact, it matches what we have right here, because this one is that, and then right here, this one is that, which matches what we have. And that answer to that question will be option A. That will be option A. And let's go to question 22. For question 22, we have that rational function. And then it's saying that we should find the domain of that rational function. Now, the first thing you have to notice is that this, for us to find the domain, it means that this denominator right here should not be equal to 0. That's the first thing I know. This denominator should not be equal to 0. So in this case, I will just take the denominator and say that that denominator should not be equal to 0. Should not be equal to 0. And then what do you notice about that denominator? I can, factor out x. X is common right here, is common right here, is common right there. So my GCF is s. And then what do I have left right here? X squared plus, what do I have left? Right here, I have 8x plus 12 is not equals to 0. And then if you simplify this carefully, and then you factor this, if you factor this, that's a quadratic, function right here. So if I factor that, what am I going to get? I'm going to have x. And then if I factor that correctly, I have x plus 2 and x plus 6 is not equals to 0. And then in this case, it means that, my x should not be equal to 0. My x should not be equal to, what is the opposite of positive 2? Negative 2. And then my x should not be equal to opposite of positive 6, negative 6. So in this case, which of the following will be my domain? Of course, my domain will be all real numbers except, x is not equal to 0, s is not equal to negative 2, s is not equal to negative 6. And that option would be option C. That option will be option C. Now let's go to question 23. For question 23, I was given an arithmetic sequence. So I was given an arithmetic sequence. T of 3 is equals to 5. T of 6 is equals to 17. What is the value of T of 10 minus T of 3? For this question, you can do this question in two ways. Is either you list all the sequence. You list all the sequence up to T10 and then you subtract. Or is another way to do it is by using the formula. So what I'm going to do right here is I am going to use the formula. You can list all the sequence because you know that the common ratio would be the addition of the preceding term, right? So I will just use the formula so that we master how to use the formula. So for the formula for this one, arithmetic sequence, I will have an is equals to ak plus d into n minus k. And then the second thing that I know is that I will decide to put T6 right here. So I decide to put T3 right here plus, I don't know my common difference. Let me find my common difference. So in this case, my n will be 6 and my k is 3. So my n 6, my k is 3. Now, if you proceed further, you notice that your T6 is 17 and then my T3 is 5 plus, what is 6 minus 3? 6 minus 3. 6 minus 3 is going to give me 3. So this one is going to give me 3D. And then in this case, what do we notice? Then in this case, I notice that 7 minus 5. So I subtract 5, I subtract 5. So now what do I have? I have 12 is equals to 3D. And then I notice that my D will be 12 divided by 3, and that one will give me 4. Now that I have my D to be equals to 4, then I can find out what T10 will be. So my T10 will be T3 plus my D is 4, and that means 10 minus 3. In this case, you have your T10. Your T3 is, from that question, is 5 plus, and then if you do the math right here, this one is going to be 28. And then once we have 28, what do you notice? This one is going to give you 33. And then in that case, I have to find out what my T8 would be. So my T8 will be T3 plus 8 minus 3 multiplied by 4. So I have multiplied by 4, and then my T8 will be 5 plus, and then if I do the math right here, this one is 20, and then this one is 25. And then what the question wants me to do is to do T10 minus T8. And then what do you notice? This one is 33 minus 25. 33 minus 25 is going to give me 8. And that option is D. That option is D. And then, as I said, there is another way to do this question. All you have to do is to find the common difference, list all the sequence up to the 10th term, and then you take the 8th term, you take the 10th term, and then you subtract. Now let's go to question 24. For question 24, we have the second term. So we have the second term of that arithmetic, sequence to be A7. AN is equals to 7. So my A2 is equals to 7. And then we were given that common difference. So my common difference is equals to -2. And then if you write down the formula we know, my formula that we know is AN is equals to AK plus D into N minus K. And then the question wants me to find the 8th term. So which means my 8th term, and then my AK is A2 minus 2, my D is minus 2, and then my N in this case will be 8 minus my K, which is equals to 2. So don't forget, my N is 8, my K is 2. And then let's do the math. Let's substitute everything we know. Of course, I am looking for A8. My A2 from the question is 7 minus 2, and then this one is 6. And then if you simplify everything that you have, you notice that your A8 is -5. So that one will give me -5, and that option is option D. Now let's go to question 25. For question 25 right here, all we have to do is to use a calculator and do something called an exponential regression in your calculator. Once you do an exponential regression, you are going to have your answer from the calculator. I just did this in the calculator not quite long. So you're going to have this answer. You're going to have 12.6501303, and then you multiply that by 2.52796 to the power of x. And then what the question is asking you to do is to find f of 2.5. So which means anywhere I see x, so anywhere you see x, you substitute 2.5. So I'll just take that 2.5 and then substitute right here and then put all of that in my calculator. And then the right answer should be that you should have this one to be 128.535. 3 decimal places. So, and the answer would be A. Don't forget, you have to use the calculator for this one. Now for question 26. Question 26 is saying that you have an exponential function g to be given as that, and A and B are positive, constant. The table gives value of G of X at a selected value of X. Which of the following is true? So the first thing I have to do, I know that exponential function, they are geometric series. So I know that exponential function, they are geometric or geometric sequence. And then in this case, all I need to do is, first of all, write down your formula for geometric sequence. So Gn is equals to Gk multiplied by R into n minus k. And then I know that this one right here is G5 is equals to 12. And then this one right here is G3 is equals to 24. And then I can use that one to calculate R. So in this case, if I decide to put my G5 right here, and then I decide to put my G3 right there, and then I'm looking for R, and then as I said, my N will be 5, and then my K will be 3. Don't forget, as I said, your N is 5 and your K is 3. And then if you proceed from there, you notice that from the question, G of 5, 12, G of 3, 24, R squared. Now let's solve this. So if you solve this, divide both sides by 24, you have your R squared is equals to 12 divided by 24. And that one is 1 over 2. And now what do you notice? You notice your R is equals to square root of 1 over 2. And that will give you 0.707. And once you have the R, you notice that that R, which is your common ratio, is the same thing, should be the same thing as your B. It will be the same thing as my B in your exponential function. So that will be 0.707. And now I have to find out. In fact, I don't have to find out what my A will be because it already told me that that A is a positive constant. So I don't have to find out what A will be. So A is greater than 0. And then now in this case, I notice that my B is between 0 and 1. So 0.707 is, this is between 0 and 1. So my B is between 0 and 1. And then a condition that has, these two conditions that has A to be greater than 0 and B to be between 0 and 1, what condition is that? That is exponential decay. That's exponential decay. And then which option says that? The option that says that is option A. And that's option A. Now let's go to the next question. Let's go to question 27. So for question 27, all I have to do in this question is to, draw this table again. So I'm going to draw a table. So let's draw a table. So I have my X. I have my f of X. And then in this case, I have -2, -5. Then I have 0, -4. I have 2, -1. I have 4 and 4. And then I have 6 and 11. Now, in this case, if you look at that, question, the question is saying the table above shows value for a function f at a selected values of x. Which of the following is true about, f that best describe the data above? So in this case, what I need to do, if you look at the answer choices, they're talking about whether this is a quadratic function, linear function, and to do that, all we have to do is to check that our x has equal length interval. So if you check your x from -2 to 0, that's +2. From 0 to 2, so from -2 to 0, that's +2. From 0 to 2, that's +2. To 2 to 4 +2, 4 to 6 +2. So my equal length interval is +2. So +2. So +2, +2 right here, +2, and then +2. So that's my equal length interval right there. And then all I need to do, because I have equal length interval, I have to do the successive difference of the output. So if I do the successive difference of the output, and then I subtract, then this one will give me 1. I subtract, this one will give me 3. Then I subtract, this one will give me 5. Then I subtract, this one will give me 7. So I'm saying 11 minus 4, 7. 1 minus minus 1, 5. Negative 1 minus minus 4, 3. Negative 4 minus minus 5, 1. And then you can see that the first difference that I did, they are not the same, right? So if they are the same, this one will have been a linear, but they are not the same. This is not linear. So this data set is not linear. And then I will do the difference again one more time. So let's do the difference again. This one will be 2. This one will be 2. And then this one will be 2. Because I did the difference twice, it means that it's going to have a degree of 2. And any function that has a degree of 2, that will be that we have a quadratic. And what answer choice describe that? That answer choice would be D. The answer choice would be D, because I did the change of the average rate of change, right? So I did the change of the average rate of change. So that will be option D. Now let's go to the next question. For the next question, we were given f of x, we were given g of x, and it's asking for what is the interval that, which g of x is greater than or equals to f of x. So how am I going to do this? I'm going to write my g of x is 2x squared plus x minus 6 is greater than or equals to my f of x is x squared minus x minus 6. And then what I want to do is I want to move everything on this side, everything on this right hand side to the left hand side. So let's move that. So if I move that, I'm going to have this minus x squared plus x plus 6 is greater than or equals to 0. Now the next thing I want to do is to simplify that. So if I simplify that, I have x squared plus 2x is greater than or equals to 0. And then if I factor out what is common, I have x plus 2 is greater than or equals to 0. Now if I find these zeros, notice my zeros will be x is equals to 0 and then negative 2, right? Because I have 2 terms right here. So I have 2 terms, so I should have 2 zeros. Now if you look at this right here real quick, this one says greater than 0. Anything greater than 0 means that it's positive, and anything equals to 0 means that the zeros are included, because we have 2 conditions right there. So we have greater than 0, which means positive, and then equals to 0, which means the zeros are included, right? So in that case, let me do my number line real quick. So if I do my number line, and I have my negative 2 right here, and then I have my 0 right here. So if I pick any number that is greater than 0, and then I test it right here. So if I pick any number greater than 0, and then I test it. So if I pick any number in this region greater than 0, and then I test it, you will notice that right here, that number is going to be positive. So it's going to be positive. And then if I pick any number between negative 2 and 0, and then test it right here, so you notice that that one will be negative. And then if I pick any number right here before negative 2 and then test it right here, you will notice that that one would be positive. And because of that, what will be my answer choice? My answer choice will be negative infinity up to negative infinity up to 2, and then or it will be 0 up to infinity, and that option will be option C. And let's go to question 29. For question 29 is saying that that exponential function is given by that which of the following describe the end behavior of that graph. So what do you do for this one? For this one, notice that your a is negative 4, Your B is 1 over 3. And then if you look at this real quick and then graph it, because you have negative, it means that the graph is going to reflect over the x-axis, right? So the graph reflects over the x-axis, and looking at the end behavior of that graph is going to be option A. So without the negative sign, we know that without this negative sign, what do you notice? That will be exponential decay. And then because that one is exponential decay because of B is between 0 and 1, then taking back this negative means I have to reflect that exponential decay over the x-axis. That's the meaning of that negative. And it will produce this end behavior right here. Let's go to the last question. The last question is question 30. Of course, I have done this question. This one means the input, and this one means the output. And then for this question, let's find out where we have our equal length interval. So our equal length interval will be right here. Plus 1, plus 1, plus 1, plus 1. So that will be my equal length interval. Of course, that is not my focus. So my focus will be on this one. So now the next question I will ask myself is, it should be either multiplication or division, right? So because we're trying to determine if this is a log function. So all we have to do, what can I multiply by 45? That is going to give me, 15. That's multiplied by 1 over 3. Multiply by 15, that will give me, 5. Multiply by 1 over 3. So everything is like multiplication of 1 over 3. Multiplication of 1 over 3. And because of that, the best answer that describes that is, this is log, because the input, so if you look at the input, because the input over the equal length output values are proportional. So you look at the input are proportional. So your input are proportional, and then the proportion is 1 over 3. And then your equal length interval is at the output. So you have to be very careful on this one. You have to read carefully on this one. Thank you so much for joining me in this part 2 of that study guide review. Please watch this video to the end, and I wish you all the best in that exam. And let me know if you have a question. I'll be happy to help.